Hello again, it's Cliff here from Down Under. RapidTurn part 25. It's weekend and I've just snuck down to the workshop for a minute, so don't tell the missus. I've finished that production run, a bunch of parts for the Hallmark impact tolerant touch probe, and it went really well. You know, I'm getting sold on CNC. I come from a manual machining tool making background, but I'm really seeing the benefits of computer controlled machines, and I did half the machining manually, one end, and the other end by CNC, and the longer I went, the more I realized, yeah, I've got to get a CNC lathe, a full CNC lathe. But even RapidTurn is 2 or 3 times better than manual turning. Alright, I'll get on with it, guys. Cheers. When I first got this Tormach 1100 back in the early days, before I did the spindle drive upgrade, I installed a spindle on a heavy machining job once. So then I fitted a Ampmeter to help me monitor how close I was to stalling when I was doing a lot of rough machining work. But also I've done a spindle drive upgrade, and I haven't had any more problems with stalling. But it's useful in a RapidTurn situation to have a look at the amperage being drawn and just see what operations are coming close to overloading RapidTurn. So let's run the part now and have a look at the Ampmeter while it's going. So we're doing OD turning now. Maximum diameter. You can see where the needle is. I don't know if this Ampmeter is calibrated correctly. While it's running, you can see the importance of having a cover on the indexing key mechanism. Well, I won't run the whole part while we're gazing at the Ampmeter because that's pretty noisy, but just to summarize, on the large diameter in the beginning of the cut, it's not drawing all that much current, but as the diameter reduces and the RPM of the part increases, the current draw is higher, and during the threading operation the current draw is quite low. So that's not exactly what I would have expected, but then electric motor current draw is not an area I have much expertise in. So just to reiterate that, the maximum current draw is when we are OD turning the small diameter roughing stage, and the depth of cut is the same as for the big diameter, so that does seem odd, but anyway, it seems to be well within the capacity of RapidTurn, the work that I'm currently doing. I've got it set conservatively so that I can wander off and do something else. And also, I don't know that this Ampmeter is calibrated correctly for the smaller RapidTurn motor, but it is a useful relative or comparative gauge. at the end of the arbors now. So I had one or two comments following the last video about drill wander and drilling concentric holes. I'll go into that a little bit more deeply, how you can save time. This applies to manual turning as well as CNC turning. You can save time getting your parts out more quickly and efficiently. So I'll go into that now. In my last video I talked briefly about trying to avoid drill wander or drill run out, where you have a hole in the middle of your part that's not concentric. And this is a very common problem for making parts, and often we don't realize until it's too late that we're producing a hole, perhaps a reamed hole, that's just not accurate. And so I touched on it in the last video, and I've had a couple of comments about that, showing interest in it. So I thought I'd try and explain it a bit better, because I didn't really explain it all that clearly. Best practice, most of you know, is to face the end of the part perfectly flat without a pip, and then carefully center it, drill a pilot hole. Perhaps you drill then a roughing hole about 1 millimeter smaller than the finished size. Let's say you have finally you have a reamed size that you're going to. So you drill a hole perhaps 1 millimeter smaller than the reamed size, and then you bore it out with a boring bar. Now this gets it perfectly concentric, and then to within maybe 4 or 5 or 6 thou of the finished size, and then ream it. Now that's best practice, but that's very time consuming. I mean, you can't do that in a production situation or you'd be at it for weeks. You need to be able to project your part out, which has been parted off previously with a through drilled hole, and now we've got a short portion of hole that's not running concentric anymore. And we don't want to have to face all that stock off and start again, because that's wasting time and material. There's a much more quick way to get a concentric hole, and I'll try and explain that now. Okay, so how do we drill a hole that doesn't have any wander or run out? Well, first of all, perhaps I should try and explain what is going wrong that's causing the run out. Well, what's going wrong is when you bring your stock out again after you've parted it off, your thread yaw chuck is not highly concentric. It's a fairly approximately concentric holding device, and the existing hole from the previous drill will have some wander, and it will be out a little bit. Or it may be out quite a lot if you're having an issue with it. So that hole, that remaining hole in the end of the stock, will be running out anywhere from 2 thou upwards, 10, even 20 thou run out. Now if you go in there with a center drill or a spotting drill, it's very likely going to pick up on that eccentric hole and produce an eccentric start for your drilling. And then if you start your drill in a center that's running out, what's going to happen? It's held at this end by the chuck in the tailstock, steady, and the other end is running out. And you can imagine if you drill more and more deeply with a drill that's running out, it's just going to project that error into a more and more extreme error. So by the time you break out at the other end, you could be running out 10, 20, 30 thou, and you're probably producing reject parts. So now that I've explained what causes it, let's look at how we can stop that from happening. Okay, so how do we stop that from happening? We've got this hole, let's say it's running out, it's off center quite a long way. Now obviously if we put a long flexible drill in there, it's just going to flex and follow that run out hole. If we put a center drill in there that's short, it's going to be more resistant to running out. And if it's in a big strong tailstock with a big strong chuck and the center drill is very sharp, it will resist run out, but it is not going to completely overcome the run out. It'll cut a tapered hole that is somewhat running out. It's virtually impossible to start with a hole that's running out and put a center in it that is perfectly concentric. It's almost impossible to do that. You need an incredibly rigid cutting tool to produce a perfectly concentric starting center. And one way you can do that is to put a ball nose cutter in there, and not any old ball nose cutter, but if you get, say, an old ball nose cutter and you grind it with more clearance so that it's very free cutting on the sides, but you know, a sharp ball nose cutter in essence that's very short and well held in a chuck. Even better than a chuck is a ER collet holder with a Morse taper to go in your tailstock. So, or hold it in a quick change tool holder so that it's very rigid, and hold that in the tool post and have a tool allocation number. Either way, you've got to hold that ball nose cutter very, very stiffly and securely. It's got to be very sharp, and you've got to advance it into the work very gently so that it's not tending to pick up on the eccentric hole but cut its own concentric hole, and that is absolutely essential. And only when you've got a perfectly concentric hole, and you can do that relatively easily with a very sharp ball nose cutter, the drill will then pick up on that concentric ball nosed cavity on its outside diameter, stay concentric, and start drilling concentric. And if you start concentric and you're holding the other end stably in the tailstock, it will keep drilling concentric, and it will stay concentric as long as the drill is sharpened evenly and has got good web thinning. And I've got some videos on that. If you look on my YouTube channel, you'll see some videos on offhand grinding and how to do that. Then you'll have a good concentric hole, and you've saved yourself facing off the end, centering, pilot drilling, boring. You can just go straight to a one drill, reamer size drill, and then ream. Okay, well, let's show that in action. Here I've got a tool in the quick change tool post that is going to provide a very rigid cutting action that will cut the centers for cylindrical grinding and also the starting cavity or center for the drill that is perfectly concentric. I'd normally run that with coolant, but I just didn't want to spray it on the camera. So that gets the outside diameter of the bore cut perfectly concentric. So whether this is a manual lathe or a CNC lathe, the same principle applies. So here I'm going to demonstrate using a very sharp ball nose cutter held very rigidly. Very light cut. Using a very light cutting force so that it doesn't follow the eccentric hole but rather cuts its own concentric pocket. And now when you start your drill, start the first small portion of the cut very sensitively and gently so that it doesn't stab in and jump off center and start with a wobble. And if your drill's sharpened correctly, you should have a curling of swarth or chip coming off each flute. I think I'll go into drill sharpening and grinding in my offhand grinding videos series part 1, is it? Anyway, you've drilled your hole. Now how do you know if it's running out? You could be producing reject parts without knowing. So if you get a drill, it's probably better to get a slightly smaller drill to be on the safe side. Put it in the part and spin the lathe and feel it. This is effectively like a dial indicator down in the bottom of the hole at the extreme end where the run out will be, if there is any. And if you hold it at this end and bias it over so that the drill is acting like a probe down in the bottom of the hole, you can measure how concentric the hole is at depth. And there you can see it's running really true. And finally, if you want a precision diameter as well as a concentric diameter, then you want to use a reamer. So you drill your hole undersize, maybe 0.2 or 0.3 of a millimeter undersize, 8 or 12 thou undersize, because the drill will cut slightly bigger than its size. And now we want the opposite to occur. We have a concentric hole and we want the reamer to follow that concentric hole, and it's got a tapered cutting edge on its end, so it will try and follow the hole. If your hole's running out, the reamer will run out. If your hole's running true, the reamer will run true. So we're going to use a fairly fast feed rate to force the reamer to follow faithfully down the hole and not try and cut its own path. Well, swarth is the enemy of precision mechanisms, so you have to do something like this, guys. It's only 5 or 10 minutes work. Find yourself a plastic tray and instant glue on a couple of strips of acrylic or polycarb, so you don't get these things getting into the indexing key mechanism and the rotary part. There's a bit of clearance around there, and I was noticing the swarth starting to build up, so do it before rather than afterwards. Well, you could be like me and go for double defense. Ah, little buggers, get out of it. Right, try getting through that. Now don't laugh. I know you think I'm paranoid, but it's not paranoia when they're really after you. I've been thinking while I've been working away how much I'm enjoying doing these videos. I mean, I've been doing stressful tool making work for decades, and now I'm able to put it into some sort of an archival order and tidy my brain up a little bit. Tool makers don't get very well paid here in New Zealand, and it's pretty stressful, poorly paid work, so it's nice to see it being appreciated by some of you folk. Looking back at some of my old photo albums, I should probably do a video series on it someday. This was a particularly stressful job where I made some neck inserts for an injection mold with the threads and spark eroding the ratchet teeth. Some really scary jobs over the years. Not so much of that anymore. While I'm in the nostalgic frame of mind, here I am back in the 70s. Young lad, started my own contract tool making business back in the 70s. And this is one particular mold that I designed and built. Gosh, it was stressful then. Pre-hardened P20 steel, no tungsten carbide, just high-speed steel bits. No digital readout, no spark eroder. One slip up and it was all over. And that was months of stress. But it was a really good grounding in the fundamentals of machining. When I was a lad, we used to walk barefoot to snow, standing at swath barefoot. Bloody luxury nowadays. CNC. CNC. Cad. Come. Bloody luxury.
But of course there isn't jobs for folks around here, and they go to RapidTurn into the city, into York. And of course if you were to talk to them in dialect, they wouldn't know what the world you were talking about.
And there we are, scores of parts. And RapidTurn performed faultlessly. All parts just came out good, the tools held up, it ran automatically while I wasn't here. I've just got 2 more to go and then I'm all done. Of course with RapidTurn you can't use big rugged roughing tools. You can use carbide, but I would advise using finishing tools. This one's particularly good. Whoa, if you use a high-end, high-quality tool, it'll last really well. This is a Sandvik TCGT 110204RK, and it's lasted the whole way through. It's a finishing tool, and you take light cuts with it, and you set the feed rate quite fast relative to the RPM, and that way you're getting good chip breaking, or rather chip curling, and short sections of chips are throwing off. It doesn't tangle up the process, and you can walk away and let it run. Well, that about wraps it up, folks. I better get upstairs to the missus again. Just one quick thing. I've been enjoying over the years using this beautiful Tessa mic with a beautiful friction thimble. It gives a beautiful feel. And I finally have given in and ordered from eBay what I thought was a good quality Chinese digital mic. And it's a Shahi. They've got a good reputation here in New Zealand as a good brand for a reasonable price. And it is a beautiful piece of work and really accurate. But you know, it's got a ratchet on it that would fit better with a socket set. Oh, it's criminal. Anyway, thanks for watching, guys. See you next time.